Science and the Modern World by Alfred North Whitehead. Quotes. Science and the Modern World by Alfred North Whitehead offers a profound exploration of the evolution of Western thought, particularly in relation to the development of modern science over the past 3 centuries. Whitehead examines how scientific advancements have significantly shaped cultural, philosophical, and intellectual paradigms. He considers the dominant worldview that emerged as science began to assert itself over older, religious, and philosophical perspectives, emphasizing the interplay of scientific, ethical, and aesthetic elements in forming human understanding of the world. The book, which grew out of the Lowell Lectures of 1925, aims to contextualize the rise of scientific thought, trace its roots, and understand its profound impact on human culture, while also probing the limitations and philosophical foundations of science itself. Quote 1. In science, Copernicus and Vesalius may be chosen as representative figures. They typify the new cosmology and the scientific emphasis on direct observation. The significance of Copernicus and Vesalius in the rise of modern science is underscored by their revolutionary contributions to their respective fields, astronomy and anatomy. Their work exemplifies a departure from reliance on traditional or doctrinal knowledge, emphasizing empirical observation and the scientific method. This shift not only transformed how we understood the cosmos and the human body, but also laid the foundation for the scientific mentality that prioritizes evidence over speculation. This mentality became a hallmark of modern science, fundamentally changing the trajectory of intellectual progress. Quote 2. The beginnings of the scientific movement were confined to a minority among the intellectual elite. The initial growth of science, in contrast to the popular religious upheavals of the time like the Reformation, was driven by a small group of thinkers rather than a mass movement. This reflects how intellectual developments, particularly in science, often start in concentrated circles of the educated before diffusing into broader society. The Reformation engaged the masses through religious reform, while science's quiet but profound transformation of thought was cultivated by a more isolated intellectual elite, indicating the different social dynamics at play in the spread of knowledge versus faith. Quote 3. This new tinge to modern minds is a vehement and passionate interest in the relation of general principles to irreducible and stubborn facts. The hallmark of the modern scientific mentality is the combination of an interest in abstract principles with a strong commitment to empirical facts. This dual focus on theory and observation distinguishes modern science from earlier approaches, where generalization often took precedence over detailed, fact-based investigation. By uniting these two elements, science developed a robust method of inquiry that seeks not only to explain individual phenomena, but to establish consistent laws governing them. This balance between facts and theory became essential for the progress of science. Quote 4. Invention stimulated thought. Thought quickened physical speculation. This quote highlights the dynamic interplay between technological advancements and intellectual developments during the birth of modern science. As new inventions emerged, they provided practical tools and examples that stimulated deeper philosophical and scientific inquiry. This process created a feedback loop, where material progress encouraged further theoretical exploration, which in turn led to more innovations. This synergy was pivotal in accelerating the progress of science during the Renaissance and beyond, showing how practical applications and speculative thought can drive mutual advancement. Quote 5. Since a babe was born in a manger, it may be doubted whether so great a thing has happened with so little stir. Here, the author compares the birth of modern science to the birth of Christ, suggesting that while both events quietly initiated monumental shifts in human history, the rise of modern science was notably understated. Unlike the religious and political upheavals that often garner immediate attention, science's profound impact on human understanding and societal development unfolded gradually and without fanfare. This comparison emphasizes the subtle yet transformative power of scientific progress in reshaping human thought and civilization. Quote 6. In science, the laws of physics are the decrees of fate. This statement draws a powerful analogy between ancient Greek ideas of fate and the workings of natural laws in science. The comparison highlights how science, like the ancient understanding of fate, deals with the inevitable and unchangeable workings of nature. The laws of physics are seen as remorseless, inescapable forces that govern the universe, just as fate governed the lives of characters in Greek tragedies. This perspective frames the scientific pursuit as a quest to understand these immutable laws, emphasizing their authority over the natural world, and positioning scientists as the interpreters of a grand cosmic order that is beyond human influence. Quote 7. Galileo owes more to Aristotle than appears on the surface of his dialogues. He owes to him his clear head and his analytic mind. This quote highlights the intellectual debt modern science owes to its predecessors, particularly Aristotle. While Galileo famously challenged Aristotelian views, especially in his works on motion, the influence of Aristotle's methodical and logical approach to understanding the world is evident in Galileo's own work. The passage suggests that even revolutionary thinkers like Galileo built on the intellectual traditions they sought to overthrow, demonstrating that progress in science often involves refining and expanding upon previous knowledge rather than outright rejection. Aristotle's emphasis on clear reasoning and systematic inquiry provided a foundational approach that shaped the development of scientific thought. Quote 8. It is this instinctive conviction, vividly poised before the imagination, which is the motive power of research, that there is a secret which can be unveiled. This statement reflects the inherent curiosity that drives scientific exploration, the belief that beneath the surface of the observable world lies an underlying order or truth waiting to be discovered. This conviction that every phenomenon can be explained through reason and observation has been a core motivator for scientists throughout history. It suggests that science is propelled not just by knowledge, but by the fundamental belief in a rational and intelligible universe which continually inspires inquiry and investigation. This faith in a hidden, discoverable truth is what has historically fueled the pursuit of knowledge and breakthroughs in various scientific disciplines. Quote 9. The first phase of the Middle Ages was an age of symbolism. In this quote, the author refers to the early medieval period as one dominated by symbolism rather than direct engagement with the natural world. During this time, intellectual and artistic efforts were more concerned with representing higher, often spiritual, ideals than with the empirical study of nature. This symbolic mindset, which focused on the metaphysical and the abstract, contrasts sharply with the later scientific mentality that emerged during the Renaissance, which emphasized observation and practical engagement with the material world. The shift from symbolic thinking to a focus on the natural world was a key factor in the rise of modern science, as it redirected intellectual energy toward understanding the laws governing the physical universe. Quote 10. The rise of naturalism in the later Middle Ages was the entry into the European mind of the final ingredient necessary for the rise of science. This passage identifies the emergence of naturalism, or a direct interest in the physical world for its own sake, as the crucial development that allowed modern science to flourish. Unlike earlier periods where nature was often viewed through a symbolic or religious lens, naturalism encouraged people to study and appreciate the natural world in its own right. This shift in perspective laid the groundwork for scientific inquiry, as it fostered a mindset that valued empirical observation and the pursuit of knowledge about the natural environment. The development of naturalism marked a turning point, enabling the detailed and methodical study of nature that became central to scientific progress. Quote 11. The science of pure mathematics, in its modern developments, may claim to be the most original creation of the human spirit. Mathematics is celebrated here as one of the greatest intellectual achievements of humanity, distinguishing itself from other forms of knowledge because it deals with abstract relationships that are not immediately apparent in everyday experiences. Unlike the knowledge derived from sensory perceptions, mathematics involves a depth of reasoning that reveals underlying patterns and connections among concepts that might otherwise remain unnoticed. This originality stems from the ability of mathematics to connect seemingly disparate elements and from its capacity to operate in realms of complete abstraction, which is something very few other disciplines can achieve. This claim is a testament to the unique role mathematics has played in the intellectual evolution of humanity, fostering a profound understanding of the order underlying both the physical world and human thought. Quote 12. The first man who noticed the analogy between a group of 7 fishes and a group of 7 days made a notable advance in the history of thought. This statement captures the profound leap that early humans made in abstract thinking, which laid the foundation for modern mathematics. The realization that numbers could be applied universally, whether to fishes, days, or any other group of objects, represented a significant step forward in the way humans conceptualize the world. It marked the transition from concrete thinking, tied to specific experiences, to abstract reasoning, which allows us to generalize across different contexts. This capacity to recognize relationships beyond the immediate and tangible is what ultimately enabled the development of mathematics as a field of study focused on exploring these relationships independently of the physical objects they describe. Quote 13. Mathematics is thought moving in the sphere of complete abstraction from any particular instance of what it is talking about. This description highlights the core nature of mathematics as a discipline that transcends specific examples and instances, focusing instead on general relationships and conditions that hold regardless of the entities involved. In mathematics, the concepts and theorems are not confined to specific cases, but apply universally to any situation that fits the defined criteria. This ability to operate within pure abstraction is what gives mathematics its power and certainty, as it allows for conclusions that are independent of the physical world and its complexities. Such abstraction is not easily grasped, but it is precisely this quality that makes mathematics a powerful tool for understanding the fundamental principles of both the natural and human-made worlds. Quote 14. The certainty of mathematics depends upon its complete abstract generality. This quote underscores the inherent reliability of mathematics, which comes from its general and abstract nature. Unlike empirical sciences, which depend on observation and can be subject to error, mathematical truths are derived from a purely logical framework that, once established, provides certainty. This certainty arises because mathematical conclusions are based on abstract principles that do not change, regardless of the specific entities they are applied to. However, applying these mathematical truths to real-world situations introduces uncertainty, as errors can occur in measurement, observation, or assumptions about the applicability of abstract principles to the physical world. Thus, the certainty of mathematics is rooted in its abstraction, while the challenge lies in correctly applying these principles to the messy realities of experience. Quote 15. The importance of an individual thinker owes something to chance. This statement reflects the unpredictable nature of intellectual influence and the role that historical context plays in determining the lasting impact of a thinker's ideas. The ideas of individuals like Pythagoras have had a profound effect on subsequent generations, partly because they resonated with later thinkers who could build upon and disseminate them. The survival and influence of these ideas are often influenced by circumstances beyond the control of the original thinker, such as the availability of students, the political climate, or the broader cultural interest in certain types of thought. This notion highlights how the evolution of knowledge is not just about the brilliance of individual minds, but also about how ideas are received, preserved, and transmitted through history, often in ways that are influenced by luck and timing. Quote 16. Classification is a halfway house between the immediate concreteness of the individual thing and the complete abstraction of mathematical notions. This statement emphasizes the role of classification in understanding the world, describing it as an intermediate step between directly perceiving individual concrete objects, and achieving the fully abstract reasoning typical of mathematics. Classification, such as categorizing plants or animals into species and genera, provides an initial framework for organizing information and understanding relationships among objects. However, to make further progress in understanding, particularly in the sciences, it is crucial to move beyond classification to the realm of mathematics, which allows for a deeper, more precise analysis of relationships and patterns. Without advancing to mathematical abstraction, classification alone is insufficient for capturing the full complexity of nature and making significant scientific discoveries. Quote 17. The dominance of the idea of functionality in the abstract sphere of mathematics found itself reflected in the order of nature under the guise of mathematically expressed laws of nature. This quote reflects how abstract mathematical concepts, especially the idea of functions, became fundamental in describing the natural world through scientific laws. During the 17th century, developments in mathematics, such as the emergence of algebraic analysis and the concept of functions, directly influenced the way scientists understood and formulated the laws governing physical phenomena. The abstract idea of functionality helped shape scientific thought, allowing complex natural behaviors to be described in a precise, quantifiable way. This transformation in thought enabled scientists like Galileo, Newton, and others to express the physical world through mathematical formulas, which in turn became the basis for predicting and understanding natural events. Quote 18. The paradox is now fully established that the utmost abstractions are the true weapons with which to control our thought of concrete fact. This statement highlights a key paradox in the relationship between abstract mathematics and the physical world. The more abstract and removed from practical reality a mathematical concept seems, the more powerful it often proves in analyzing and controlling concrete phenomena. The 17th century advances in mathematics, which involved developing highly abstract theories and tools, ultimately provided the means to make sense of and manipulate the physical world with unprecedented accuracy. This paradox underscores the importance of abstract thinking in scientific progress, showing that understanding fundamental truths about the universe often requires departing from immediate, tangible experiences and venturing into highly theoretical realms. Quote 19. The birth of modern physics depended upon the application of the abstract idea of periodicity to a variety of concrete instances. The emergence of modern physics was significantly driven by applying the abstract mathematical concept of periodicity, regular recurrence, to various physical phenomena. The recognition that many natural processes, from planetary orbits to sound waves, exhibited periodic behavior allowed scientists to use trigonometry and other mathematical tools to model and predict these phenomena. This application of periodicity facilitated major breakthroughs in understanding nature, such as explaining the motion of celestial bodies and the behavior of light and sound. By identifying a common mathematical structure underlying diverse physical systems, early physicists were able to unify different branches of natural philosophy into a coherent scientific framework, marking the beginning of modern physics. Quote 20. The importance of the abstract idea of periodicity was thus present at the very beginning both of mathematics and of European philosophy. This quote emphasizes that the concept of periodicity, recurring cycles, was crucial not only in the development of mathematics, but also in shaping European philosophical thought from the very beginning. Pythagoras and his followers understood the significance of periodicity, particularly in relation to music and harmony, which in turn influenced their broader philosophical ideas about the nature of reality. This early recognition of periodic patterns laid the foundation for later scientific and mathematical developments, highlighting how abstract concepts can provide fundamental insights into the structure of the world. The continuity of this idea from Pythagoras through the scientific revolutions of the 17th century and into modern physics demonstrates its enduring importance in understanding both the natural and conceptual realms. Quote 21. The historical revolt was the definite abandonment of this method in favor of the study of the empirical facts of antecedents and consequences. This statement marks the transition during the 17th century away from purely rationalistic approaches that relied on abstract metaphysical reasoning to understand the world, towards an empirical method that prioritized observation, experimentation, and induction. This shift was crucial in developing modern science as it emphasized understanding natural phenomena by examining their causes and effects in concrete, observable ways, rather than relying on speculative reasoning. This change in methodology laid the foundation for scientific inquiry as we know it today, providing a systematic approach that allowed for the validation and falsification of theories based on empirical evidence, leading to significant advances in our understanding of the natural world. Quote 22. The men of this epoch inherited a ferment of ideas attendant upon the historical revolt of the 16th century, and they bequeathed formed systems of thought touching every aspect of human life. The intellectual life of the 17th century is depicted here as both a product of the cultural and philosophical upheavals of the previous century and as a period of profound creative synthesis. The scientists and philosophers of this time took the diverse and often chaotic ideas that emerged during the Reformation and the Renaissance and transformed them into structured systems that influenced every domain of human thought. This period produced foundational works in fields ranging from philosophy and natural science to political theory, which not only advanced knowledge in those areas, but also provided subsequent generations with frameworks that would shape intellectual discourse for centuries to come. This transformation underscores the unique role of the 17th century as a formative period in shaping modern Western intellectual traditions. Quote 23. Induction presupposes metaphysics. This quote reveals an important philosophical insight about the process of induction, which is central to scientific inquiry. The author argues that for induction to be meaningful, it must be grounded in a prior understanding of the nature of reality, essentially a metaphysical foundation. Without some underlying belief that the universe is orderly and that future events will resemble past ones, inductive reasoning becomes baseless. This highlights the often overlooked relationship between scientific methods and the philosophical assumptions that support them. Even empirical science, which prides itself on objective observation and reasoning, relies on deeper, abstract principles about the world that cannot themselves be derived from empirical evidence alone. Quote 24. By the end of the century, physics had been founded on a satisfactory basis of measurement. This statement captures a major achievement of the 17th century, establishing physics as a quantitative science. By the late 1600s, scientists like Newton had defined key physical quantities such as mass and force, and formulated laws that described their relationships using precise mathematical measurements. This emphasis on quantification represented a significant shift from earlier approaches that relied more on qualitative descriptions and classifications. It provided the basis for modern physics, where laws and theories must be expressed in a form that allows for measurement, prediction, and mathematical analysis. This transformation was key to the success of classical mechanics and set the stage for later developments in physical sciences, engineering, and technology. Quote 25. The concept of an ideally isolated system embodies a fundamental character of things, without which science, or indeed any knowledge on the part of finite intellects, would be impossible. This quote discusses the importance of the concept of an isolated system in scientific reasoning. In order to study natural phenomena, scientists often simplify complex systems by treating them as isolated from external influences. This abstraction allows for clearer understanding and more precise predictions about how the system behaves under controlled conditions. The concept of isolation is crucial because it makes it possible to apply laws of physics in a consistent manner, free from unpredictable influences. This idea also reflects the limitations of human cognition. To comprehend the vast complexity of the universe, we often need to break it down into simpler, manageable parts. The use of isolated systems is thus fundamental to the progress of scientific knowledge, enabling us to develop laws and theories that describe the natural world effectively. Quote 26. New ideas have a certain aspect of foolishness when they are first produced. This statement acknowledges the initial reception that innovative ideas often face. When new concepts are first introduced, they can seem radical or nonsensical, partly because they challenge established norms and understanding. This perspective is particularly relevant to scientific revolutions, where breakthroughs often defy conventional wisdom and provoke skepticism. It serves as a reminder that the value of a new idea is not always immediately apparent, and that history has shown time and again how such seemingly foolish ideas can transform our understanding of the world. Quote 27. The answer which the 17th century gave to the ancient question of the Ionian thinkers, "What is the world made of?" was that the world is a succession of instantaneous configurations of matter. This quote highlights the foundational understanding of the universe that emerged in the 17th century, which saw the world as composed of matter in a series of distinct momentary states. This mechanistic view suggests that the universe operates through successive snapshots of material arrangements, governed by predictable physical laws. This perspective was instrumental in shaping the scientific revolution, providing a basis for Newtonian physics and mechanistic explanations of natural phenomena. However, it also introduced limitations, as it had relied on the concept of static configurations and struggled to address more dynamic and interconnected aspects of nature. Quote 28. The great forces of nature, such as gravitation, were entirely determined by the configurations of masses. This statement reflects the mechanistic view of nature that dominated 17th century science, where the behavior of fundamental forces like gravity was explained purely in terms of the spatial arrangement of physical masses. In this framework, the universe was seen as a deterministic system, where the interactions between objects were entirely predictable based on their positions and the forces acting upon them. This understanding was central to the development of classical mechanics, allowing for precise mathematical descriptions of planetary motion and other physical phenomena. However, it also exemplified the limitations of a purely materialistic worldview that could not easily account for more complex or emergent properties of nature. Quote 29. The order of nature cannot be justified by the mere observation of nature. This quote reveals a philosophical limitation in the mechanistic view of nature, that simply observing the world cannot provide a complete justification for the underlying regularities that make scientific prediction possible. The idea is that the consistency and predictability of natural laws cannot be explained solely by looking at the physical phenomena themselves. Instead, there must be some deeper principle or metaphysical framework that accounts for why these regularities exist in the first place. This notion foreshadows later philosophical debates about the basis of natural laws, emphasizing the need for something beyond empirical observation to explain the coherence and stability of the natural world. Quote 30. Nature is a dull affair, soundless, scentless, colorless, merely the hurrying of material, endlessly, meaninglessly. This quote critiques the reductionist perspective that emerged from the scientific developments of the 17th century, where the natural world was stripped of its sensory richness and reduced to mere physical interactions. According to this view, qualities like color, sound, and scent are not inherent properties of the external world, but are instead subjective experiences created by the human mind. The material world, when viewed through this lens, becomes devoid of intrinsic meaning or beauty. It is simply a mechanical process, indifferent and impersonal. This reductionist approach was highly effective for advancing scientific knowledge, but also led to a worldview that many found philosophically unsatisfactory, lacking any deeper sense of purpose or meaning. Quote 31. The 18th century in Europe was the complete antithesis to the Middle Ages. This quote reflects the stark contrast between the intellectual and cultural climates of the 18th century and the Middle Ages. The Middle Ages were characterized by a strong focus on faith and the desire to rationalize the infinite, often through religious and metaphysical means. In contrast, the 18th century emphasized reason and the rationalization of society, focusing more on empirical knowledge and practical human concerns. This shift marked a significant change in the priorities of intellectual inquiry, moving away from abstract theological questions toward addressing social structures and the natural world based on observable facts and reason. Quote 32. The earlier period was the age of faith, based upon reason. In the later period, they let sleeping dogs lie. It was the age of reason, based upon faith. This statement highlights the reversal in the relationship between reason and faith from the Middle Ages to the 18th century. During the Middle Ages, faith was built on a foundation of reason. Thinkers like St. Anselm sought rational proofs for the existence of God to support their beliefs. By contrast, the 18th century reversed this relationship, with reason operating under an implicit, unexamined faith in the order of nature. This shift illustrates how intellectual movements can evolve, maintaining a balance between reason and belief, but changing the emphasis and approach. It underscores the idea that both epochs relied on a combination of reason and faith, but prioritized them differently in the pursuit of understanding the world. Quote 33. The real error is an example of what I have termed the fallacy of misplaced concreteness. This quote introduces the concept of the fallacy of misplaced concreteness, which refers to mistaking abstract concepts for concrete realities. The scientific scheme of the 17th century, particularly its notions of simple location and isolated entities, was an abstraction designed to make the complexity of nature easier to understand and manipulate mathematically. However, the problem arose when these abstractions were taken as fully representative of the actual nature of reality, rather than as simplified tools for understanding it. This fallacy led to a distorted view of the world that ignored the interconnectedness and dynamic complexity inherent in nature, contributing to philosophical confusion and limiting our understanding of more holistic and relational aspects of existence. Quote 34. We cannot overrate the debt of gratitude which we owe to these men. For 1,000 years, Europe had been a prey to intolerable visionaries. This statement recognizes the significant contributions of 18th century thinkers in breaking away from the oppressive intellectual climate that had dominated Europe for centuries. The author acknowledges the importance of figures like Voltaire and others who championed common sense, reason, and the questioning of established authority. Their work represented a departure from the rigid dogmatism and mystical thinking of the past, which often stifled intellectual and social progress. By promoting ideas such as justice, individual rights, and the rational inquiry, these thinkers helped to create an environment that was more conducive to scientific and social advancement, laying the groundwork for modern democratic societies. Quote 35. The triumph of materialism was chiefly in the sciences of rational dynamics and physics and chemistry. This quote explains how materialism, an outlook that views the universe in purely physical terms, gained dominance through its successes in fields like physics, chemistry, and dynamics during the 18th century. In these sciences, the materialistic perspective proved to be extraordinarily effective, allowing for precise mathematical modeling and prediction of natural phenomena. This led to a view of the universe as a vast mechanism fully comprehensible through the principles of mechanics and chemistry. The success of materialism in these disciplines solidified its position as the prevailing worldview, influencing how people thought about everything from the physical sciences to human behavior. However, this triumph also meant that other perspectives, particularly those related to the qualitative and subjective aspects of experience, were marginalized or dismissed. Quote 36. Space-time cannot in reality be considered as a self-subsistent entity. It is an abstraction, and its explanation requires reference to that from which it has been extracted. This quote emphasizes that space-time should not be viewed as an independent, fundamental entity. Instead, it is an abstraction derived from the events and their relationships within the universe. Space-time is merely a conceptual tool used to describe certain general characteristics and the ordering of events. This perspective shifts the focus from seeing space-time as a concrete framework in which everything happens to understanding it as an abstract construct that depends on the concrete realities of individual occurrences. Recognizing this abstraction helps in critiquing the limitations of previous scientific models, which often treated space-time as an ultimate self-sustaining reality without considering the more fundamental events that give rise to it. Quote 37. The point before us is that this scientific field of thought is now, in the 20th century, too narrow for the concrete facts which are before it for analysis. This quote suggests that the scientific concepts developed in previous centuries, though successful, have become insufficient for addressing the complexities of modern science. The framework, created during the 17th and 18th centuries, was highly effective for explaining basic physical phenomena, but it lacks the capacity to fully account for newer, more complex challenges, particularly in fields like biology and physics. As scientific inquiry progresses, the abstractions and simplifications that once worked well are now seen as inadequate, necessitating a broader, more comprehensive approach that can better align with the richness of our intuitive experiences and the intricate nature of the physical world. Quote 38. Berkeley, in effect, criticizes this notion. He also raises the question, what do we mean by things being realized in the world of nature? This quote points out that Berkeley fundamentally questioned the concept of simple location, the idea that objects have fixed, definite positions in space and time without reference to anything else. He challenged the assumption that we can talk about objects existing independently, without considering the context of perception. In doing so, he highlighted the need to rethink what it means for something to be real in the natural world, questioning whether objects can exist unobserved or whether their existence is inherently tied to being perceived. This line of questioning opens up a critique of materialistic and mechanistic views that dominated scientific thought, emphasizing the role of perception and context in defining reality. Quote 39. It is the perspective of the castle over there from the standpoint of the unification here. This quote illustrates a shift from the idea of simple location to a more relational understanding of perception. When we perceive a distant object, such as a castle, we are not perceiving the castle as it exists independently, but rather the aspect or perspective of the castle relative to our current location. This suggests that perception is inherently about relationships rather than isolated entities. It underscores that the unity of perception is always contextual. What we perceive is shaped by where we are and the conditions under which we observe. This approach challenges the notion that objects can be fully understood as separate from their observers, emphasizing the importance of the relational aspects of perception. Quote 40. The strength of the theory of materialistic mechanism has been the demand that no arbitrary breaks be introduced into nature to eke out the collapse of an explanation. This quote emphasizes that one of the key strengths of the theory of materialistic mechanism lies in its insistence on consistency and continuity within nature. It rejects any arbitrary interruptions or gaps that cannot be explained scientifically. This principle has allowed mechanistic science to build a framework of understanding where everything is interconnected and follows predictable patterns. However, while this approach has led to many successes in explaining natural phenomena, it also limits the ability to account for complex, holistic aspects of nature, such as consciousness or organic unity, that do not fit neatly into a mechanistic model. The challenge lies in expanding scientific thought to embrace a broader understanding of these more complex aspects without losing the rigor of the mechanistic approach. Quote 41. The 18th century continued the work of clearance with ruthless efficiency. This statement reflects how the 18th century pursued the rational and scientific advancements initiated in the 17th century by further stripping away older beliefs and systems of thought. The era was characterized by its commitment to rationality and its willingness to discard anything that could not be justified by logical analysis or empirical evidence. This ruthless efficiency helped to clear the way for modern scientific inquiry, emphasizing objectivity and the power of human reason, However, this process also led to a narrowing of perspectives, where elements that could not be easily quantified or explained were marginalized or ignored. This created a gap between the mechanistic view of the universe and the more organic, experiential aspects of human life. Quote 42. A scientific realism, based on mechanism, is conjoined with an unwavering belief in the world of men and of the higher animals as being composed of self-determining organisms. This quote points out a fundamental inconsistency in modern thought, which simultaneously holds two conflicting views. On the one hand, there is scientific realism, which sees the world as a mechanism governed by predictable deterministic laws. On the other hand, there is an unwavering belief in the autonomy and agency of human beings and animals as self-determining entities. This tension between seeing nature as a machine and recognizing the freedom and responsibility inherent in living beings creates a philosophical contradiction that weakens modern thought. The coexistence of these two conflicting ideas highlights the difficulty of fully integrating the mechanistic model of science with the experiential reality of life and consciousness. Quote 43. Wordsworth opposes to the scientific abstractions his full concrete experience. This quote captures Wordsworth's reaction against the reductionist approach of 18th-century science. He believed that the scientific focus on abstraction and analysis failed to capture the true essence of nature, which he experienced in a much richer, more concrete way. For Wordsworth, nature was not just a collection of measurable parts, but a living presence, filled with meaning and emotional depth. His poetry reflects an attempt to reconnect with the full reality of nature, resisting the dissection and simplification that science often imposes. Wordsworth's approach emphasizes the importance of subjective, experiential understanding as a necessary complement to objective scientific analysis, suggesting that the full richness of nature can only be grasped when both perspectives are considered. Quote 44. Each molecule blindly runs. The human body is a collection of molecules. Therefore, the human body blindly runs, and therefore, there can be no individual responsibility for the actions of the body. This quote articulates the troubling implications of a purely mechanistic view of the universe, particularly when applied to human beings. If everything, including the molecules that make up the human body, follows deterministic laws and blindly runs without purpose or direction, then it follows that human actions are also predetermined and devoid of any real agency. This view challenges the concept of individual moral responsibility, as it implies that our behavior is entirely dictated by mechanical processes beyond our control. Tennyson and other poets of the Romantic era grappled with this issue, as it seemed to undermine the very idea of free will and the moral accountability that is central to human identity. This perspective highlights the limitations of strict materialism in accounting for the complexities of human experience, such as choice, purpose, and ethical responsibility. Quote 45. For Shelley, nature retains its beauty and its color. This quote highlights Shelley's perception of nature as fundamentally beautiful, vibrant, and full of color. Contrary to the reductionist view often proposed by scientific materialism, Shelley did not strip nature of its qualities, such as color and beauty, which the mechanistic worldview often reduces to mere sensory illusions with no independent reality. Instead, he retained a vision of nature as a living, meaningful entity, filled with the qualities that make it significant to human experience. Shelley's refusal to treat these secondary qualities as illusions speaks to his broader rejection of the idea that science can fully capture the essence of the natural world. For Shelley, nature is not simply a collection of abstract, measurable components, but an interconnected, dynamic presence filled with qualities that enrich human life. Quote 46. Shelley thinks of nature as changing, dissolving, transforming as it were at a fairy's touch. This quote describes Shelley's fascination with the mutable, ever-changing aspects of nature. He saw the natural world as in constant transformation, like a magical spectacle unfolding before us, where nothing stays static. His imagery evokes a sense of fluidity, where the elements of nature continually shift, dissolve, and reform. For Shelley, this dynamic transformation is not just about physical movement, but involves an inner transformation of character and essence. This focus on change as an intrinsic quality of nature stands in contrast to the stability and endurance that Wordsworth found significant. Shelley's vision emphasizes the fleeting, elusive beauty of nature, suggesting that its essence lies in its continuous renewal and transformation. Quote 47. Wordsworth was haunted by the enormous permanences of nature. This quote captures Wordsworth's focus on the enduring and stable aspects of nature. Unlike Shelley, who was drawn to nature's changing and ephemeral qualities, Wordsworth found inspiration in its unchanging, timeless presence. The mountains, the rivers, and the hills represented a sense of permanence that contrasted with the transient experiences of human life. To Wordsworth, these enduring aspects of nature carried deep meaning, acting as a grounding force that provided stability and continuity across time. His poetry reflects a profound appreciation for this constancy, seeing in it a reflection of something eternal that offers solace and a deeper understanding of existence. This perspective suggests that amidst the chaos of human affairs, there is a natural order that endures, providing a sense of continuity and spiritual reassurance. Quote 48. Philosophy is the critic of abstractions. This quote defines the role of philosophy as the discipline that examines and critiques the abstractions created by science and other fields of thought. Philosophical inquiry is concerned with understanding the limitations and relative validity of these abstractions, ensuring that they are not mistaken for the complete picture of reality. Philosophy seeks to harmonize different abstractions, assess their scope, and place them in the context of broader, more concrete experiences of the universe. It does not generate its own isolated set of abstractions like science, but rather serves to integrate and complete them by relating them to the complexities of lived experience. By critiquing abstractions, philosophy aims to prevent any single perspective from becoming overly dominant, thereby promoting a more balanced and comprehensive understanding of reality. Quote 49. Nature is a structure of evolving processes. The reality is the process. This quote presents a vision of nature not as a collection of static objects, but as a dynamic interplay of evolving processes. In this view, reality itself is constituted by these processes, continuous flows of change, interaction, and development. This understanding of nature aligns with the organic and process-oriented perspectives championed by the Romantic poets, and contrasts with the mechanistic worldview that sees nature as composed of unchanging entities. The emphasis here is on the fact that everything in nature is in a state of becoming rather than simply being, and that this process of becoming is what constitutes true reality. It challenges us to see the world not as a fixed structure, but as an ongoing series of events and transformations, where the meaning of each part is found in its relationship to the whole, and its role in the unfolding process of nature. Quote 50. The whole change has arisen from the new scientific information. This quote underscores the fundamental role of scientific knowledge in driving the transformative changes of the 19th century. The advancements in technology and the new methods of invention were made possible by the increased availability of scientific information. Science provided the raw ideas and theories that inventors and engineers could then apply to create practical innovations. This relationship between science and technology created a feedback loop where scientific discoveries spurred new inventions, and these inventions, in turn, opened new avenues for scientific exploration. The 19th century witnessed a unique convergence of scientific inquiry and practical application, which dramatically reshaped society and fueled the Industrial Revolution. Quote 51. The 19th century, the process became quick, conscious, and expected. This statement reflects how the pace and nature of technological change shifted dramatically in the 19th century. Whereas earlier technological progress was often slow, sporadic, and accidental, the 19th century saw change become rapid, intentional, and something that people came to anticipate. The Industrial Revolution, fueled by scientific advancements and new methods of invention, created an era where innovation was no longer a rare event, but a continual process. This transformation changed how societies functioned and how individuals viewed progress, instilling a sense of expectation that new technologies would continually improve living conditions and capabilities. This shift to a culture of rapid and predictable technological progress had profound social, economic, and cultural impacts that are still felt today. Quote 52. The transformation of the field of knowledge, which has been thus effected, has not been wholly a gain. This quote suggests that while the technological and scientific advancements of the 19th century brought undeniable benefits, they also introduced new challenges and potential downsides. The increase in efficiency and the rapid accumulation of knowledge created a new kind of society, one that was more dependent on technology and specialized expertise. This transformation brought about significant changes in social structures, work environments, and human relationships with nature, some of which were not entirely positive. The new reliance on technology and professional specialization sometimes led to a loss of connection with traditional ways of life and a growing sense of alienation. Thus, while the advancements were impressive, they also posed risks that needed careful consideration to ensure that progress was truly beneficial for all of humanity. Quote 53. The modern theory presupposes happenings in that field which are divorced from immediate dependence upon matter. This quote addresses the changing understanding of physical theories during the 19th century, particularly regarding the concept of fields, such as electromagnetic fields. Unlike earlier materialistic views that required a physical medium, like ether, to explain such fields, the modern theory began to move away from the need for such direct dependence on matter. The idea of fields represented a significant shift in scientific thought, emphasizing the importance of abstract forces and interactions rather than concrete physical entities. This change marked a departure from traditional materialism, where everything was explained in terms of matter and its interactions. Instead, the new theories focused on the relationships and forces that exist independently of any underlying material substance, reflecting a more complex and nuanced view of the natural world. Quote 54. The greatest invention of the 19th century was the invention of the method of invention. This statement emphasizes that the true breakthrough of the 19th century was not any single invention, but rather the development of a systematic method for inventing itself. This method involved applying scientific knowledge in a disciplined and organized manner to solve practical problems. It transformed invention from a process reliant on individual genius or luck into a systematic and repeatable practice. This shift enabled a rapid acceleration in technological advancements and made innovation an expected part of human progress. The invention of the method of invention laid the groundwork for the Industrial Revolution and modern technological development, making the process of creation efficient, predictable, and capable of sustained progress. Quote 55. The position here maintained is that the relationships of an event are internal, so far as concerns the event itself. That is to say, that they are constitutive of what the event is in itself. This quote reflects a philosophical stance that the relationships between elements of an event are fundamental to the event's identity. In other words, what an event is cannot be separated from the interactions and relationships that define it. These relationships are not external additions, but are inherent to the nature of the event itself. This perspective challenges a more traditional, mechanistic view that sees relationships as merely external factors acting upon independent entities. Instead, it posits that the very essence of an event is shaped by the web of interactions it is part of, suggesting a more interconnected, organic view of reality. Quote 56. The underlying activity, as conceived apart from the fact of realization, has three types of envisagement. This quote refers to a conceptual framework in which the underlying activity, a foundational force or process, has three distinct aspects of potentiality or envisioning. These aspects are the envisagement of eternal objects, abstract entities, or ideals, the envisagement of potential values that can arise from combinations of these eternal objects, and the envisagement of the actual circumstances that can be achieved by realizing these potentials. This framework suggests that the underlying force of reality encompasses not only the potential forms that could exist, but also the value judgments and contextual circumstances that shape how these potentials manifest in the world. This comprehensive approach underscores the depth and complexity of the processes that underpin existence, emphasizing that value, form, and context are all integral to the unfolding of reality. Quote 57. The atomic material entities which are considered in physical science are merely these individual enduring entities, conceived in abstraction from everything except what concerns their mutual interplay in determining each other's historical roots of life history. This quote explains that the entities studied in physical science, such as atoms, are abstracted from their broader contexts and interactions. Physical science tends to isolate these entities, focusing only on how they interact with each other to determine their historical trajectories. However, this abstraction leaves out many other aspects of their existence, such as their broader environmental influences and internal complexities. This approach allows scientists to model and predict physical interactions effectively, but it also simplifies the nature of these entities by ignoring the rich context in which they exist. Recognizing these limitations is important when considering the applicability of scientific laws beyond the specific conditions under which they were formulated. Quote 58. The note of the present epoch is that so many complexities have developed regarding material, space, time, and energy that the simple security of the old orthodox assumptions has vanished. This quote captures the essence of the shift in scientific understanding during the modern era. The established, comfortable assumptions about matter, space, time, and energy that dominated scientific thinking since Newton's time have been fundamentally challenged. These concepts, which once provided a secure foundation for understanding the natural world, have become increasingly complex, leading to uncertainties and the need for reorganization in scientific thought. This shift indicates a departure from the simplicity of classical materialism towards more sophisticated and abstract theories, such as relativity and quantum mechanics. The evolution of these ideas reflects how new experimental evidence and advances in theoretical frameworks have rendered the older models inadequate, forcing a reassessment of our fundamental understanding of reality. Quote 59. The new situation in the thought of today arises from the fact that scientific theory is outrunning common sense. This statement points out that the advancements in scientific theory have reached a level of abstraction that surpasses everyday human experience, or common sense. In earlier times, scientific theories were often extensions of what people could observe or reasonably infer from their daily lives. However, with the development of theories like relativity and quantum mechanics, science has ventured into realms that defy intuitive understanding. Concepts like the relativity of time and space, the behavior of particles at the quantum level, and the bending of space-time by gravity challenge the fundamental ways in which people naturally perceive the world. This growing divide between scientific knowledge and common sense has created a more complex intellectual landscape, requiring new ways of thinking and understanding that are not immediately accessible through everyday experience. Quote 60. The ground of the explanation is that the ideas of space and of time employed in science are too simple-minded and must be modified. This quote explains why the classical notions of space and time have proven insufficient for understanding the complexities revealed by modern experiments, such as those involving the speed of light. The traditional, simple-minded concepts of space and time, where they are treated as separate, absolute entities, cannot adequately explain the results of experiments like Michelson's interferometer, which showed that the speed of light is constant regardless of the observer's motion. This finding led to the need for a radical revision of these fundamental concepts, culminating in Einstein's theory of relativity. In this new framework, space and time are not independent, but are intertwined into a four-dimensional space-time continuum that changes depending on the observer's frame of reference. This modification represents a significant departure from the classical view, illustrating the evolving nature of scientific understanding in response to new evidence. Quote 61. The modern scientific assumption is that if anything has the speed of light by reference to any one meaning of space and time, then it has the same speed, according to any other meaning of space and time. This quote describes one of the foundational principles of Einstein's theory of relativity: the constancy of the speed of light. According to relativity, the speed of light in a vacuum is always the same, regardless of the motion of the source or the observer. This principle is counterintuitive because it contradicts the classical expectation that velocities should be additive. For example, if a car is moving towards you, classical mechanics would predict that its speed would appear greater if you are also moving towards it. However, relativity asserts that the speed of light remains constant, regardless of the relative motion of the observer. This concept has profound implications for our understanding of space and time, leading to effects such as time dilation and length contraction, where the passage of time and measurements of distance vary depending on the observer's frame of reference. Quote 62. This is a heavy blow at the classical scientific materialism, which presupposes a definite present instant at which all matter is simultaneously real. This quote highlights how the theory of relativity challenges the classical notion of an absolute universal present moment that is the same for all observers. In classical mechanics, time is treated as a constant that flows uniformly, allowing for a clear, definite now that applies to all matter simultaneously. However, relativity rejects this idea, showing that what is perceived as the present can differ for observers in different states of motion. There is no single, universal now that encompasses all of reality. Time is relative and depends on the observer's frame of reference. This realization undermines the deterministic framework of classical materialism, which relies on the idea of a fixed and shared timeline for all events, replacing it with a more fluid and observer-dependent understanding of time and simultaneity. Quote 63. The note of the present epoch is that scientific theory is outrunning common sense. This quote emphasizes that contemporary scientific developments, particularly those involving theories of relativity, have gone beyond what is intuitively understandable in everyday human experience. In earlier periods, scientific theories were grounded in observable phenomena and common sense. However, as the understanding of space, time, and energy advanced, the explanations and concepts proposed by modern science, such as the relativity of time and the curvature of space-time, have become more abstract, challenging traditional notions of reality. This shift demonstrates the widening gap between our natural intuitive understanding of the world and the sophisticated, often counterintuitive models required to explain the complexities revealed by recent scientific discoveries. Quote 64. Every enduring object is to be conceived as at rest in its own proper space, and in motion throughout any space defined in a way which is not that inherent in its peculiar endurance. This quote suggests that each enduring object has its own unique reference frame in which it can be considered at rest, while it may appear to be in motion when viewed from other reference frames. This idea is central to the theory of relativity, which posits that motion is always relative to a particular frame of reference. Objects that are at rest in one frame may be in motion when viewed from another, depending on how space and time are defined in each. The concept challenges the classical notion of a fixed, absolute space and time, highlighting the importance of understanding that different observers may perceive the motion and rest of objects differently, depending on their own states of motion and the reference frames they use. Quote 65. If there be no one definite meaning to the geometrical relations of distance, it is evident that the law of gravitation needs restatement. This statement points out that if distance cannot be defined consistently across all situations due to the relative nature of space and time, then Newton's law of gravitation which relies on a single fixed concept of distance, must be revised. In classical physics, the gravitational force between two masses is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This formula assumes that there is a universal and unchanging way to measure distance. However, the theory of relativity reveals that space and time are not fixed, and thus the concept of distance can vary depending on the observer's frame of reference. As a result, Einstein reformulated the law of gravitation to incorporate these complexities, leading to a more generalized theory of gravitation that accounts for the curvature of spacetime caused by mass and energy. Quote 66. The internal relatedness is the reason why an event can be found only just where it is and how it is. That is to say, in just one definite set of relationships. This quote highlights the idea that the relationships constituting an event are intrinsic to its nature. In other words, an event's identity is defined by the network of internal relationships that characterize it, which means it cannot be separated from these relationships. Unlike classical views that consider spatial and temporal relationships as external and additional to the entities they connect, this view posits that these relationships are part of the essence of the event itself. This concept challenges the classical notion of isolated objects interacting in an external framework of space and time, suggesting instead that events are defined by the intrinsic web of connections they share with other elements in the universe. Quote 67. Thus, time is sheer succession of epochal durations. This quote describes time as a series of discrete epochal durations rather than a continuous flow. In this view, time is not infinitely divisible, but consists of distinct units or epochs, each with its own duration. This concept contrasts with the traditional view of time as a continuous, unbroken stream. By defining time as a sequence of discrete moments, the theory aims to address paradoxes like Zeno's, which arise from the assumption of infinite divisibility. This notion of time being atomic or chunked into distinct epochs has significant implications for how we understand temporal processes, suggesting that the flow of time is a series of distinct, indivisible events rather than a smooth, continuous progression. This perspective is particularly relevant in the context of quantum theory, where the behavior of particles often seems to occur in discrete steps rather than continuous changes. Quote 68. The point of interest in this theory is that, according to it, some effects which appear essentially capable of gradual increase or gradual diminution are in reality to be increased or decreased only by certain definite jumps. This quote captures the essence of quantum theory, which revolutionized the understanding of physical processes. Unlike classical physics, which assumes that changes in energy or states occur smoothly and continuously, quantum theory posits that changes happen in discrete amounts, or quanta. This means that certain effects cannot be divided infinitely. They occur in specific, indivisible steps. This notion challenges the classical view of gradualism, introducing a fundamental limit to how changes in nature can occur. The concept of energy being emitted or absorbed only in distinct packets fundamentally altered the understanding of atomic and subatomic processes, providing the basis for much of modern physics and leading to technologies like lasers and semiconductors. Quote 69. The waves of light were explained in terms of the locomotion of a material ether, and the internal happenings of a molecule are now explained in terms of the locomotion of separate material parts. This quote explains the historical context of how light and molecular activities were understood in classical physics. The ether was a hypothetical substance believed to fill space and serve as the medium through which light waves traveled, much like sound waves traveling through air. Similarly, molecular dynamics were described in terms of physical parts moving within an atom. This materialistic approach aimed to provide a concrete, mechanistic explanation for natural phenomena. However, with the advent of quantum theory, this understanding began to shift, as the behavior of light and subatomic particles could not be fully explained by classical models of material motion alone, leading to a more abstract and probabilistic framework in modern physics. Quote 70. The quantum theory wants trolley cars with a limited number of routes, and the scientific picture provides horses galloping over prairies. This vivid analogy highlights the difference between quantum theory and classical physics. Quantum theory, represented by trolley cars with a limited number of routes, suggests that energy and particles follow specific, defined paths or states, implying a level of restriction and precision. In contrast, the classical view is depicted as horses galloping over prairies, suggesting freedom and continuity without specific limitations. This analogy underscores the fundamental shift that quantum theory introduced. Instead of assuming that particles could occupy any state continuously, quantum theory posits that they can only occupy certain discrete states, which is a significant departure from the classical understanding of unrestricted, continuous variation in nature. Quote 71. Perhaps you noticed that, in a previous chapter, I used the word reiteration as a synonym of endurance. It obviously is not quite synonymous in its meaning, and now I want to suggest that reiteration where it differs from endurance is more nearly what the organic theory requires. This quote reflects on the concept of endurance versus reiteration within the organic theory of nature. Endurance traditionally implies something that remains the same over time, unchanged and stable. In contrast, reiteration suggests a repetition that may involve variation or transformation while maintaining a core essence. The organic theory, as proposed here, favors the idea of reiteration because it aligns more closely with how patterns or organisms sustain themselves not through static existence, but through dynamic repetition and adaptation. This perspective allows for the unfolding of complex, aesthetic contrasts over time, similar to how a piece of music unfolds in sequence rather than remaining fixed, thus emphasizing the fluid and evolving nature of enduring entities in the universe. Quote 72. The discontinuities introduced by the quantum theory require revision of physical concepts in order to meet them. This quote acknowledges that the discontinuities inherent in quantum theory necessitate a fundamental rethinking of existing physical concepts. The classical view of the physical world as continuous and deterministic is incompatible with the discrete, probabilistic nature of quantum events. Quantum theory reveals that at the smallest scales, processes do not occur in a smooth, predictable fashion, but rather in sudden jumps, which challenges the traditional notions of continuity and causality. To accommodate these findings, physicists must revise the foundational principles of how they understand motion, energy, and the behavior of particles. This need for revision reflects the broader impact of quantum theory on reshaping the conceptual framework of physics, moving away from the certainty of classical mechanics to embrace a more nuanced and complex understanding of nature. Quote 73. The origin of modern philosophy is analogous to that of science and is contemporaneous. This quote highlights that modern philosophy emerged alongside the scientific revolution, sharing a similar origin in terms of timing and intellectual foundation. Both fields experienced a major transformation during the 17th century, when thinkers began to reject medieval scholasticism and instead sought new, systematic ways of understanding the world. This shift led to the development of methods and principles that emphasized reason, empirical observation, and a return to foundational sources of knowledge, such as those provided by Greek philosophy. The philosophical movement was influenced by the same individuals who were shaping scientific thought, which helped intertwine the development of philosophical and scientific ideas during this transformative period. Quote 74. Modern philosophy is tinged with subjectivism, as against the objective attitude of the ancients. This quote indicates a fundamental shift in the focus of modern philosophy compared to ancient philosophy. While ancient philosophers, such as Plato and Aristotle, were primarily concerned with objective reality, the external world and its laws, modern philosophy shifted its attention to the subject, emphasizing individual experience and perception. This subjectivist trend is evident in the works of thinkers like Descartes, who famously declared, "I think, therefore I am," establishing the self as the starting point of philosophical inquiry. This inward focus reflected broader cultural shifts, including the influence of Christianity, which stressed the importance of the individual soul. Consequently, modern philosophy became increasingly concerned with understanding how knowledge is formed within the individual mind, exploring the processes of thought, perception, and consciousness. Quote 75. The ancient world takes its stand upon the drama of the universe, the modern world upon the inward drama of the soul. This statement contrasts the philosophical outlooks of the ancient and modern worlds. Ancient philosophers were preoccupied with understanding the cosmos, the grand objective reality outside the individual. They sought to understand the natural order and the place of humanity within it, treating the universe as a stage for all existence. In contrast, modern philosophy has shifted its attention inward, focusing on the personal subjective experience of the individual. The inward drama of the soul reflects an emphasis on personal consciousness, self-awareness, and the process of gaining knowledge. This inward turn marks a significant divergence in philosophical priorities, with modern thinkers more concerned with understanding the nature of the self and the mechanisms of perception and cognition. Quote 76. The anti-rationalism of the moderns has checked any attempt to harmonize the ultimate concepts of science with ideas drawn from a more concrete survey of the whole of reality. This quote suggests that the modern scientific approach, characterized by anti-rationalism, has limited efforts to integrate scientific concepts into a broader, more holistic understanding of reality. Anti-rationalism in this context refers to the reluctance to apply abstract, philosophical reasoning to explain scientific phenomena. Instead, science focused on empirical evidence and practical methodologies, often resisting attempts to connect its findings to overarching philosophical principles. This compartmentalization led to a disconnect between science and philosophy, with science focusing solely on observable phenomena and avoiding broader metaphysical interpretations. As a result, philosophy lost its role as a unifying framework that could provide a deeper understanding of the interconnectedness of all aspects of reality, leading to a fragmented view of knowledge. Quote 77. The 17th century dualism cut straight across it. The objective world of science was confined to mere spatial material with simple location in space and time, and the subjective world of philosophy annexed the colors, sounds, scents, tastes, touches, bodily feelings, as forming the subjective content of the cogitations of the individual minds. This quote describes the dualistic separation that emerged in the 17th century between the objective and subjective realms. Science focused on the objective world, reducing it to quantifiable material entities that existed independently in space and time. These entities were studied as external objects, governed by laws that could be measured and predicted. In contrast, philosophy was left with the subjective aspects of experience, qualities such as color, sound, and sensation, which were considered part of the internal life of the mind. This division led to a fundamental problem in modern thought: understanding how subjective experiences relate to the objective world. By isolating subjective experiences as mere products of the mind, the dualistic approach created a gap between the physical reality studied by science and the qualitative richness of human experience, leading to ongoing debates about the nature of perception, consciousness, and reality itself. Quote 78. Bergson introduced into philosophy the organic conceptions of physiological science. This quote emphasizes that Henri Bergson brought an organic and biological perspective into philosophy, challenging the mechanistic worldview of the 17th century. Bergson's approach moved away from the rigid, static materialism that had previously dominated Western thought, proposing instead that life and consciousness cannot be fully understood through the purely mechanical and spatial frameworks established by Newtonian physics. He argued that such conceptions are mere abstractions and do not capture the essence of living processes. Bergson's philosophy emphasized the fluid, dynamic nature of life and time, rejecting the reduction of life to spatial terms and instead focusing on the temporal and evolutionary character of living beings. His views marked a shift towards a more holistic and integrated understanding of nature, one that aligns more closely with modern biology's perspective on living organisms. Quote 79. The private psychological field is merely the event considered from its own standpoint. This statement highlights the concept that an individual's psychological experience can be understood as the subjective perspective of an event. In this view, the psychological field is not an aggregation of parts, but is a unified entity representing the event as experienced by the individual. This perspective underscores the importance of understanding psychological phenomena in terms of their holistic nature, rather than attempting to break them down into isolated components. It also implies that individual consciousness is a unique integration of various happenings, giving rise to a cohesive experience that cannot be reduced to a mere sum of its parts. This approach supports an organic view of psychology, where the unity of experience is fundamental to understanding the nature of consciousness. Quote 80. The primary situation disclosed in cognitive experience is ego-object amid objects. This quote asserts that the fundamental experience of consciousness involves the self, or ego, situated among other objects in the world. It suggests that cognitive experience is inherently relational, defined by the interaction between the self and the external environment. The ego object represents the conscious self as it perceives and interacts with its surroundings, which include other objects and entities. This perspective challenges the traditional Cartesian dualism that separates the mind from the external world. Instead, it posits that the self is always engaged in a dynamic relationship with its environment, and this relationship is fundamental to the nature of cognition. By emphasizing the interconnectedness of the self with the external world, this view aligns with an organic understanding of consciousness, where the boundaries between self and other are fluid and interconnected. Quote 81. The organic starting point is from the analysis of process as the realization of events disposed in an interlocked community. This quote describes the organic approach to understanding reality, which begins by analyzing processes as the unfolding of events that are interconnected within a larger community. Unlike the materialistic view that starts with independently existing substances, the organic perspective emphasizes the relational and processual nature of existence. Events are not isolated but are part of an interdependent web, where each event influences and is influenced by others. This interconnectedness creates a cohesive community of events, which together form the fabric of reality. The organic view thus sees the world as a dynamic, evolving system of relationships, rather than a collection of static, self-contained entities. This perspective is particularly relevant in fields such as ecology and systems theory, where the focus is on understanding how different elements interact and contribute to the overall functioning of a system. Quote 82. The effect of physiology was to put mind back into nature. This quote suggests that advancements in physiology helped to reintegrate the mind into the natural world, countering the earlier philosophical separation between mind and matter. In the 17th century, dualistic thinking led to a strict division between the physical body and the mind, treating the latter as something separate from the natural, physical processes of the body. However, physiology demonstrated that mental processes are deeply connected to the physical functioning of the body, particularly the nervous system. By showing how mental states are influenced by physiological conditions, this field of study helped bridge the gap between mind and nature, supporting a more unified, holistic view of human beings. This reintegration aligns with the organic philosophy, which views mind and body not as distinct entities, but as interconnected aspects of a single integrated organism. Quote 83. The notion of material, as fundamental, has been replaced by that of organic synthesis. This quote highlights a significant shift in the conceptual foundation of understanding reality. In the past, materialism, which considered physical matter as the basic building block of the universe, was the dominant perspective. However, this approach has been replaced by a view that emphasizes organic synthesis, an interconnected, process-oriented approach that sees all aspects of reality as dynamically related and evolving together. This shift reflects a move away from viewing the universe as composed of isolated static particles toward seeing it as an integrated, living system in which all elements participate in a larger, organic whole. This perspective not only captures the complexity and interrelatedness of natural processes, but also aligns more closely with contemporary scientific developments that emphasize the importance of relationships and interactions in understanding the nature of existence. Quote 84. An actual occasion is to be conceived as a limitation, and that this process of limitation can be still further characterized as a gradation. This statement introduces the idea that each actual event, or occasion, is not an all-encompassing entity, but rather a selective limitation of the possibilities that could exist. The process of an event coming into being involves choosing from a wide range of potential outcomes, thus limiting what becomes actual. This limitation can also be understood as a gradation, where certain possibilities are realized more fully than others, creating a hierarchy of relevance or significance within the event. This concept emphasizes that reality is not a simple binary of possible versus actual, but instead involves varying degrees of realization, where some elements are fully expressed, while others remain as background potential. This nuanced view provides a deeper understanding of how events unfold in a world rich with possibilities. Quote 85. The understanding of actuality requires a reference to ideality. This quote asserts that to fully comprehend the nature of actual events, one must consider ideals or abstract possibilities that extend beyond any specific occasion. Actuality, the concrete reality we experience, is always shaped in reference to ideal possibilities, those abstract concepts or eternal objects that provide the potential forms and values that events can realize. This relationship between actuality and ideality means that the world we experience is not self-sufficient. It is always informed by a broader realm of possibilities that gives it meaning and structure. Ideality provides the framework for understanding why things are the way they are, offering a deeper insight into the choices and patterns that underlie the manifestation of actual events. Quote 86. An eternal object is to be comprehended by acquaintance with I, its particular individuality, its general relationships to other eternal objects, and chatutiti, the general principle which expresses its ingression in particular actual occasions. This statement explains how one can understand an eternal object, a fundamental abstract concept that exists beyond any single event. First, each eternal object has its unique individual nature that defines what it is in itself. Second, it has general relationships to other eternal objects, meaning that its existence is interwoven with a network of relationships that define its role within a larger system of abstract possibilities. Finally, the ingression of an eternal object into actual events refers to how it becomes part of a particular occurrence, contributing to the character of that event. Together, these aspects explain how eternal objects relate to both the abstract realm of possibilities and the concrete world of actual events, providing the bridge between ideal concepts and their realization in the physical world. Quote 87. Every occasion is a synthesis of being and not being. This quote encapsulates the idea that every actual event involves both realization and exclusion. When an event occurs, it synthesizes certain possibilities, making them part of its being, while simultaneously excluding others, thus representing their not being. This means that what an event becomes is defined not only by what it includes, but also by what it leaves out. This synthesis of being and not being is fundamental to how events shape themselves, as the exclusion of certain possibilities is as crucial as the realization of others in defining the character of an event. It emphasizes that every moment of actuality is a selective process, determining which potentialities are brought into reality and which are not, thereby shaping the unique nature of each occasion. Quote 88. An actual occasion is the superject of informed value. This quote defines an actual occasion as a superject that embodies informed value. Unlike a subject, which passively receives experiences, a superject is actively formed through the integration and realization of potential values into concrete existence. It represents the culmination of various possibilities becoming actualized in a particular moment or event, thus adding unique value to the universe. This concept highlights the dynamic nature of reality, where each occasion contributes something new and meaningful to the ongoing process of becoming. It emphasizes the active role of actual occasions in shaping reality, rather than merely being passive entities affected by external forces. Quote 89. The spatio-temporal scheme is, so to speak, the greatest common measure of the schemes of relationship, as limited by actuality, inherent in all the eternal objects. This statement explains that the spatio-temporal framework serves as a kind of universal reference system that organizes the relationships of eternal objects as they are manifested in actual occasions. It acts as the greatest common measure by providing a common context in which different entities and relationships can be expressed, thereby making them compatible with one another in the actual world. The spatio-temporal scheme limits the otherwise unlimited possibilities inherent in eternal objects, grounding them within the boundaries of space and time, so that they can participate in the physical reality. This framework thus enables the abstract relationships of eternal objects to become realized in the concrete world, providing a structured environment in which events unfold. Quote 90. An eternal object, such as a definite shade of green, which cannot be analyzed into a relationship of components, will be called simple. This quote defines simple, eternal objects as those that cannot be broken down into smaller components or relationships. An example of a simple eternal object is a particular shade of green, which exists as a distinct, indivisible quality. Unlike complex, eternal objects that can be analyzed in terms of their constituent relationships, simple eternal objects represent fundamental, irreducible aspects of experience. These simple entities form the building blocks of reality, providing the basic elements that can combine with others to create more complex structures and relationships. Understanding these simple eternal objects is crucial for grasping the foundational aspects of how reality is constructed and how more intricate phenomena emerge from these fundamental elements. Quote 91. There is an analysis of the realm of possibility into simple eternal objects and into various grades of complex eternal objects. This quote describes the hierarchical nature of eternal objects, which can be categorized into simple and complex types. Simple eternal objects are those that are indivisible and represent basic qualities, while complex eternal objects are composed of relationships among simpler components. This analysis of the realm of possibility reveals a structured hierarchy, where more complex forms are built upon simpler foundational elements. The idea of grades of complexity suggests that there is an organized progression from basic entities to more intricate relationships, highlighting the layered nature of reality. This structure provides a framework for understanding how different levels of abstraction interact and contribute to the richness of the universe. Quote 92. The existence of such an infinite abstractive hierarchy is what is meant by the statement that it is impossible to complete the description of an actual occasion by means of concepts. This statement emphasizes the inherent limitation of trying to fully describe an actual occasion using concepts alone. Each actual occasion is associated with an infinite abstractive hierarchy, which consists of an endless progression of increasingly complex relationships and abstractions. Because of this infinite complexity, any attempt to describe an actual occasion with concepts will inevitably fall short, as it cannot capture the full richness of its interconnections and possibilities. This highlights the limitations of language and conceptual analysis in fully encapsulating the dynamic and evolving nature of reality. The infinite depth of an actual occasion means that there will always be aspects that transcend our conceptual understanding, pointing to the need for experiential and intuitive engagement with reality as a complement to rational analysis. Quote 93. In the place of Aristotle's God as prime mover, we require God as the principle of concretion. This quote presents a shift from Aristotle's conception of God as the prime mover, whose role was to initiate motion and sustain cosmic harmony, to a more nuanced role as the principle of concretion. In Whitehead's philosophy, God is not just an initiator of movement, but is crucial for the actualization of possibilities into concrete reality. The principle of concretion refers to the process by which potentialities are shaped into actual particular occurrences in the world. This redefined concept of God emphasizes the active role of divine influence in determining the specific forms that emerge from the realm of infinite possibilities. It positions God not merely as a distant cause, but as intimately involved in the ongoing processes of the universe, guiding the actualization of values and forms. Quote 94. Every actual occasion is a synthesis of all occasions, under the limitation of gradations of types of entry. This quote describes how each actual occasion, a concrete event in the unfolding of the universe, synthesizes the influences of all other occasions within certain limits. These types of entry refer to the different ways in which past, present, and potential future events can contribute to shaping a particular occasion. Each occasion is an intersection of influences, including both the relationships among other occasions and the eternal objects, abstract potentials, that become realized. This synthesis occurs with a limitation. Each occasion does not fully integrate everything, but rather selects from the available possibilities, thereby creating a unique combination that defines its existence. The concept of synthesis with limitations highlights the interconnectedness of all events, where each moment is shaped by its relationships to the entire universe, while also emphasizing the role of selection and constraint in defining what becomes actual. Quote 95. The unity of all actual occasions forbids the analysis of substantial activities into independent entities. This statement asserts that the interconnected nature of all actual occasions prevents us from treating individual activities as isolated independent entities. Instead, every occasion is part of a larger unified process that encompasses all other occasions. This holistic view challenges the traditional idea of treating parts of reality as fully separate or self-contained. Instead, it suggests that every activity and entity is inherently linked to the broader web of existence, with its nature and behavior influenced by its relationships with everything else. This perspective is central to Whitehead's process philosophy, which views reality as fundamentally composed of interdependent events rather than discrete substances. It underlines the idea that understanding any part of reality requires understanding its place within the whole, as no entity exists entirely apart from the rest. Quote 96. God is the ultimate limitation, and his existence is the ultimate irrationality. This quote conveys a complex and provocative idea about the nature of God in Whitehead's Metaphysics. Here, God is described as the ultimate limitation, because his role is to provide the fundamental constraints that shape the universe. Without these constraints, the world would be a chaotic realm of infinite possibilities without any specific actualization. The term ultimate irrationality suggests that there is no reason or rationale behind the particular way in which God imposes these limitations. These fundamental decisions are beyond explanation. They represent the starting point of all rational inquiry, but are themselves not subject to reason. This conception of God acknowledges both the necessity of divine influence for providing order and the mystery inherent in the ultimate source of limitation, which lies beyond human comprehension. Quote 97. The envisagement which enters into the synthesis is also a character which conditions the synthesizing activity. This quote emphasizes the role of envisagement in the process of creating an actual occasion. Envisagement involves envisioning the possibilities that can be realized in the synthesis of an event. This imaginative aspect helps shape the activity of synthesis by providing a vision of the potential forms that can emerge. In other words, the act of considering what is possible influences how those possibilities are ultimately realized. This envisagement is not passive. It actively conditions and directs the creative process that leads to the actualization of an occasion. By including envisagement as part of the process, Whitehead highlights the creative and purposive aspects of how reality unfolds, suggesting that the universe is not merely a mechanical system, but one that involves intentionality and vision in the realization of possibilities. Quote 98. There has always been a conflict between religion and science, and in the second place, both religion and science have always been in a state of continual development. This quote addresses the historical relationship between religion and science, emphasizing that conflict between them is not a new phenomenon. Throughout history, the two have often been at odds, as each has sought to explain different aspects of reality. However, this conflict is part of an ongoing evolution, as both religion and science are dynamic and constantly changing fields. Religion has evolved by adjusting its doctrines to new understandings, while science has continually refined its theories as new evidence becomes available. This ongoing development implies that the apparent conflicts between religion and science are not insurmountable, but are instead part of a larger process of growth and adaptation. It suggests that rather than seeing their disagreements as final, we should recognize them as opportunities for both to refine and deepen their insights into the nature of existence. Quote 99. Science is even more changeable than theology. This quote points out that scientific theories are not static, but subject to frequent revision as new discoveries are made. While theology also evolves, scientific knowledge changes at an even faster pace due to the empirical nature of the scientific method, which relies on ongoing experimentation and observation. Theories that were once considered definitive, such as those of Newton, have been revised or even replaced as new evidence and ideas have emerged. This fluid nature of science contrasts with the perception of religion as unchanging, highlighting that both fields are in fact evolving, albeit in different ways and at different speeds. The dynamic character of science exemplifies the provisional nature of human understanding, where each discovery opens up new questions and necessitates further exploration. Quote 100. In formal logic, a contradiction is the signal of a defeat, but in the evolution of real knowledge, it marks the first step in progress towards a victory. This statement underscores the idea that contradictions in knowledge are not inherently negative, but are instead opportunities for advancement. In formal logic, contradictions are considered errors that undermine the validity of an argument. However, in the context of science and religion, contradictions can indicate areas where current understanding is incomplete or inadequate. These contradictions motivate deeper investigation, leading to new discoveries or insights that resolve the apparent inconsistencies. This perspective suggests that the conflict, whether between different scientific theories or between science and religion, is a natural part of the process of expanding knowledge. Instead of avoiding or dismissing contradictions, embracing them as opportunities for growth is a fundamental aspect of intellectual progress. Quote 101. Religion is tending to degenerate into a decent formula, wherewith to embellish a comfortable life. This quote conveys a concern that religion, in its contemporary form, is losing its deeper spiritual vitality and is instead becoming a mere social convention. Rather than serving as a profound source of meaning and purpose, religion is often reduced to a set of rituals or moral guidelines that provide comfort and order but lack transformative power. This decent formula serves to decorate an already comfortable existence rather than challenging individuals to seek a deeper understanding of the divine or to live with a sense of adventure and spiritual quest. The quote highlights the need for a reinvigoration of religious practice and belief, one that inspires true devotion and a pursuit of higher values beyond mere comfort. Quote 102. Religion is the vision of something which stands beyond, behind, and within the passing flux of immediate things. This quote offers a definition of religion as a vision that transcends the transient, material aspects of life. Religion points to something greater that gives meaning to existence, something that is both deeply embedded in reality and yet also beyond the immediate, visible world. It is an ideal that inspires worship and offers a sense of purpose that goes beyond the temporal and mundane. This vision is not static. It evolves and deepens over time as individuals and societies seek to understand it more fully. Religion, in this sense, provides a connection to the eternal and the meaningful, offering a perspective that gives coherence and value to the fleeting experiences of everyday life. Quote 103. Importance depends on endurance. Endurance is the retention through time of an achievement of value. This quote emphasizes that the significance of anything lies in its ability to endure over time. The value of any action, idea, or creation is measured by its lasting impact or ability to persist through changing circumstances. Endurance is the capacity to retain a form or essence across time, demonstrating resilience and stability. This concept is essential in understanding the progression of ideas, social structures, and achievements within human history. When something endures, it retains its value and influence, suggesting that enduring patterns or values are those most worth pursuing. In this way, endurance becomes a key criterion for determining what is genuinely important and meaningful in both individual lives and societal development. Quote 104. The emergent individual value of each entity is transformed into the independent substantial existence of each entity, which is a very different notion. This quote discusses a conceptual shift that occurred in modern thought, particularly influenced by Cartesian dualism. Initially, the individual value of an entity was seen as its inherent worth within a larger interconnected system. However, this value was mistakenly transformed into the idea that each entity exists as an independent, self-contained substance. This shift led to a fragmented understanding of the world, where objects and beings were seen as isolated rather than interdependent. Such a view is fundamentally different from understanding entities as having emergent value through their relationships with other parts of the system. This misinterpretation contributed to the mechanistic worldview of the 17th and 18th centuries, which saw the universe as a collection of disconnected, self-sufficient parts, rather than as an organic whole in which everything is intrinsically linked. Quote 105. The modern professionalism in knowledge works in the opposite direction, so far as the intellectual sphere is concerned. This quote highlights the effects of specialization in modern knowledge, pointing out that while professional training in specific fields has allowed for significant advancements, it has also created intellectual silos. Specialists in one discipline often lack knowledge in other areas, which leads to a fragmented intellectual landscape where people are deeply knowledgeable in their fields, but disconnected from a broader understanding. This situation results in minds in a groove, where individuals may excel within their narrow domains, but fail to appreciate the interconnectedness of various forms of knowledge. The fragmentation caused by modern professionalism poses a risk to broader intellectual development and societal cohesion, as it limits the ability to integrate knowledge across disciplines, which is essential for addressing complex challenges that require holistic understanding. Quote 106. Wisdom is the fruit of a balanced development. This statement suggests that true wisdom arises from a balanced and well-rounded development of the individual. It is not enough to excel in a specialized field. Wisdom requires integrating different forms of knowledge and understanding the world from multiple perspectives. A balanced development involves cultivating both intellectual and emotional faculties, combining specialized knowledge with an appreciation for the broader context in which that knowledge fits. This holistic approach enables individuals to make better judgments, navigate complexities, and appreciate the subtleties of life. Wisdom, therefore, is not merely a matter of accumulating facts or skills, but involves nurturing a deep understanding that comes from seeing the interconnections between different aspects of reality and maintaining a sense of proportion and perspective. Quote 107. The death of religion comes with the repression of the high hope of adventure. This quote reflects the idea that religion loses its vitality when it ceases to inspire a sense of adventure and aspiration. Religion, at its core, is meant to evoke a quest for the transcendent, a pursuit of something greater than oneself. When religious practice becomes rigid, formulaic, or overly focused on rules and doctrines, it loses the spirit of exploration and aspiration that makes it meaningful. This high hope of adventure refers to the spiritual journey that involves taking risks, seeking deeper truths, and embracing the mystery of existence. Without this sense of adventure, religion becomes lifeless, reduced to mere ritual without the transformative power that can inspire individuals and communities to strive for higher ideals. Quote 108, "There are two principles inherent in the very nature of things, recurring in some particular embodiments, whatever field we explore, the spirit of change and the spirit of conservation." This quote describes the dual principles that underlie all aspects of existence, the spirit of change and the spirit of conservation. The spirit of change represents the dynamic aspect of reality, the constant movement and evolution that characterizes life and the universe. On the other hand, the spirit of conservation embodies the need to preserve continuity and maintain stability amidst this change. Both principles are essential, as mere change without conservation leads to chaos and instability, while conservation without change results in stagnation and an inability to adapt. The interaction of these two forces ensures that reality evolves while retaining some elements of continuity, striking a balance between progress and stability. This balance is reflected across different levels of existence, from the natural world to social and cultural systems, emphasizing that all forms of life depend on the interplay of growth and preservation. Quote 109, "A self-satisfied rationalism is, in effect, a form of anti-rationalism. It means an arbitrary halt at a particular set of abstractions." This quote criticizes a form of rationalism that becomes complacent and stops questioning or exploring further. True rationalism should always push beyond current understandings and continue seeking new insights rather than settling comfortably on established abstractions. When rationalism becomes self-satisfied, it effectively turns into anti-rationalism because it resists the natural drive to expand and refine knowledge. This leads to a stagnation of thought, where existing concepts are treated as ultimate truths, preventing further intellectual development. The danger of this mindset is that it prevents people from reevaluating and questioning their beliefs, thereby missing opportunities for growth and deeper understanding. In essence, rationalism must continually transcend itself, returning to the concrete world for new inspiration and avoiding the temptation to rest on the laurels of established ideas. Quote 110, "The soul would wither without fertilization from its transient experiences." This quote emphasizes the importance of new and varied experiences for the growth of the soul. Without fresh inputs and the stimulation of transient events, those moments that come and go but leave an impact, the soul becomes stagnant, losing its vitality and depth. The soul thrives on a balance between permanence and change. It needs the stability of enduring values, but also the novelty and richness that comes from encountering new circumstances. This process of fertilization through transient experiences allows the soul to grow, adapt, and enrich itself. It suggests that personal growth and fulfillment are rooted not only in holding on to enduring principles, but also in engaging fully with the changing world around us, which keeps the spirit vibrant and evolving. Quote 111, "The transitions of humor, wit, irreverence, play, sleep, and, above all, of art, are necessary for it." This quote highlights the various elements that are essential for the health and well-being of the human soul. Elements such as humor, wit, irreverence, play, sleep, and especially art serve as necessary transitions that provide the soul with moments of refreshment and escape from the monotony of life. These activities allow the mind to break free from rigid routines, offering a release that is crucial for mental and emotional well-being. Art, in particular, plays a significant role in enriching the soul by presenting vivid yet fleeting experiences that help individuals connect with deeper values and beauty. These forms of transition are not trivial. They are fundamental to maintaining a balanced, enriched, and resilient inner life, helping to sustain the vitality of the human spirit amidst the demands and stresses of daily existence. Quote 112. Modern science has imposed on humanity the necessity for wandering. This quote suggests that the advancements in modern science have made it essential for humanity to embrace a mindset of continuous exploration and change. Science, with its constant progression and technological innovations, has altered the way humans interact with their environment and understand their place in the universe. This has imposed a kind of intellectual and existential wandering, where individuals must adapt to new knowledge, face challenges that come with technological change, and venture into unknown territories of thought and experience. The necessity for wandering implies that a static, settled existence is no longer possible or desirable. Instead, humanity must be willing to explore new ideas, adapt to new circumstances, and accept the uncertainty that comes with scientific and technological progress. This wandering is not merely physical, but also involves spiritual, intellectual, and cultural journeys that challenge individuals to grow and evolve in response to the ever-changing world. Science and the Modern World by Alfred North Whitehead leaves the reader with a powerful understanding of how science has redefined the human experience and reshaped our perception of reality. Whitehead challenges us to reconsider the limitations of scientific materialism, pointing out the need for a more holistic perspective that includes the aesthetic, ethical, and philosophical dimensions of existence. His reflections invite a re-evaluation of the balance between science and other modes of inquiry, suggesting that true progress lies not only in scientific discovery, but also in the integration of different ways of understanding the world. Ultimately, the book serves as both a celebration of scientific achievement and a call for an enriched worldview that embraces the complexity of human thought and experience.
Curious to dive into the mind of Alfred North Whitehead? With StudyLab Pro's Book GPT, it's possible. Ask questions, explore themes, and discover the depths of science and the modern world in an entirely new way. Start your conversation now by clicking on our logo. And if you're hungry for more educational content, subscribe to our channel to keep discovering, learning, and growing. Want more than just videos? Click on our logo now to join us on our platform for multiple choice tests, in-depth content, and tools to help you ace your studies. Get started now.